right, we're going to look at a review of random variables. So this is, how should I say it? The problem that you're going to be given will likely say the words random variable. Something is a random variable. Be on the lookout for that phrasing so that you know that this is the approach you're going to take. So here are what the formulas look like. These are on your formula sheet, but you might want to write them down. Maybe if you're making your own kind of formula sheet. This is the formula for mean of a random variable. This is the formula for standard deviation. If they want variance, just remember that variance is the standard deviation squared. So you would just take all of this and square it. Okay. Here are how to interpret the mean and the standard deviation. The mean is also known as the expected value. So especially if a problem asks you how many of whatever would you expect to get, that would be implying that they want you to find expected value or the mean. So if we repeat whatever the scenario is many times, we would expect to get whatever that mean is on average per trial. And then this is how we interpret standard deviation. It's always an approximate average that things are away from the mean. And then again, you can write those down, have them handy. Hopefully you have like a sheet of interpretations that we've been slowly building. Here is how you get on your calculator, if you want to get the mean and the standard deviation using your calculator. So an example would be like if you have a problem like this and they want to know what the expected value is. So what I would suggest doing is right away writing the formula for expected value. And again, if you go back a few pages, formula is right here. We gotta at least have the formula. So I'm gonna write that out. Okay, and then what I'm going to do is type this stuff in my calculator. Which is right here. Okay, typed it down 2 lists, labeled it Y and PY. Okay, there's the data right there. And then what I'm going to do is, after I get the data typed in, I'm going to go to a blank page and I'm going to do Menu, Statistics, Stat Calculations, One Variable Stats. I am going to keep it at 1 list, even though we typed in 2 lists. Keep it at 1 list. Call this whatever the first list was. It was Y. And then the frequency list is PY. Those are the probabilities attached to each of these Y values. It's like a weighted average. Hit OK. And then you might have to scroll up a little bit, but right here is the mean, 2.73. And then right here is the standard deviation, 1.25583. And again, if you missed it, the directions are right here. Now this was a different list, but the idea is the same. So when we did it on our calculator, we got 2.73 for this expected value. Now the variance, be careful of the wording, the variance was not given to us in the calculator. This is the standard deviation. So what we have to remember is that the variance is the standard deviation squared. So if I write out my standard deviation formula and all this kind of stuff, again, this formula was a couple slides back, so you could rewind to see it. Okay, this is standard deviation and it was 1.25583. But if I want the variance is the standard deviation squared. So I need to do 1.25583 squared. And what will we get? We get 1.2 57711. Okay, now here is a bunch of formulas that you're going to want to have written down. These are not on the formula sheet. So on a regular AP test, this stuff was difficult for students. But now that you can have open notes and you can make your own formula sheet, you should definitely write all these down. So when you are adding random variables, you are allowed to just add up their means. And we are allowed to add up their variances, but we don't add the standard deviations. Okay, if you want the standard deviation, all you have to do is take the square root of what you got for the variance. So I would always find the variance first, then take the square root of the variance to get the standard deviation. If you are subtracting random variables, you are allowed to subtract their means, but watch out here, you still add the variances. Okay, don't subtract standard deviations. Okay, if you want the standard deviation of two random variables subtracted, just do the square root of the variance. And again, the variance is up here. We add the variances, even if we're subtracting random variables. So make a note of that because that is something that is easy to forget. When we are adding a constant or subtracting a constant, you are allowed to add that constant to the mean. But we do not add a constant to a variance or to a standard deviation. So the variance remains unchanged. Even if we're adding a constant, the variance stays the same. So the standard deviation will also just stay the same. Oops. There. Well, I'll fix it. Okay, so the variance stays the same, so does the standard deviation. Here is when you are multiplying by a constant. So you can multiply the mean by the constant. And then if you're doing variance, you can multiply by the constant squared. See how everything is squared? And if we took the square root of all of this to get the standard deviation, you would just get that constant times the standard deviation of x. So bottom line is that the means do everything they're told to do. You can add means, you can subtract means, you can add or subtract a constant, you can multiply by a constant. The means are usually not the problem. It's the standard deviations that get tricky. So we add variances and take the square root to get the standard deviation. We still add variances even when we're subtracting. We still add the variances, take the square root to get the standard deviation. Adding a constant or subtracting a constant does not change the variance or the standard deviation. And then if you are multiplying by a constant, you can multiply the standard deviation by that constant, or you can multiply the variance by the constant squared. So put all of those down on some sort of formula sheet. Here's an example of where you're going to use this concept. Okay, I think that this is highly likely to show up on the AP test. All right, so if I read through the problem, and you'll recognize this because we've done it before, but we've got a salesman. The number, it says it's an approximately random variable m. So this salesman is a random variable. So I know right there that these formulas are going to apply. All right, so this random variable m has a mean. So the mean for m is 4.12, and the standard deviation for m is 1.39. I would write them down like that just to help. Then we have a new person, and they also are a random variable n, and they have a mean of 3.36 and a standard deviation of 0.88. Okay, now the main heart of the problem is asking what is the probability that the two salesmen sell more than 10 units? So it's the old guy plus the new guy working together. So we are adding random variables. Okay, so if we realize we're adding random variables, then we are going to use these formulas here at the very top. So, oops, went the wrong way. So to get the mean of my two guys together, I can take the old guy's mean and add the new guy's mean to it. So I'm going to get 4.12 plus 3.36, and my combined mean will be 7.48. Now, to get the standard deviation, I cannot add the standard deviations. So I cannot add these two together. But I can do the variances. So I'm going to do the variance of m plus n. So that'll be taking the variance of m plus the variance of n. Okay, so that the variance will be this 1.39 squared. And then the variance of n would be the 0.88 squared. When I add those up, I get 2.7065. Now, if I want the standard deviation, which I do, I'm going to take the square root of what I got from my variance. So I will get 1.64514. All right, so this is all the background work. Okay, so this is my mean. This is my standard deviation. And now what I'm ultimately trying to figure out is the probability that the old guy plus the new guy sell more than 10 units. Okay, now here's another clue. It said approximately normal up here in the paragraph. And so that is going to imply z-scores. Okay, so let's find the z-score for this scenario. 10 is the value we're trying to be more than, minus the mean of 7.48, divided by the standard deviation of 1.64514. And when I type that in my calculator, my z-score is going to be 1.53. So going back over here, this is the same thing as my z-score being more than 1.53. Since it's a greater than, we're going to do 1 minus, and I would get out my z-chart and I would look up 1.53 on the z-chart, and that is 0.9370. Subtract that from 1 and you get your final answer of 0.063. Okay, and that is your final answer. But all of this work is required. You need to show how you get your new mean and your new standard deviation. You need to show your z-score work, and you need to show all of your probability stuff, as well as your final answer. Okay? Now here is a little variation on this. I think this will be our last example for random variables. Yes, it is. So it's the same scenario, and this time I want the probability that the new guy sells more than the old guy. So the new guy sells more than the old guy, N greater than M. Well, what you run into an issue with is the fact that like down here we were adding and we had a number right here. And I don't have that in this case, but I can be clever and I can subtract the M over to the other side. So if I'm subtracting M, I'll have nothing there. Now I can see that I'm subtracting random variables. And when you realize you're subtracting random variables, you're going to be using the second row here. So remember, we subtract the means, but we still add the variances. So just as a little reminder, the mean of M, gotta rewrite this down. The mean of M was 4.12. The standard deviation of M was 1.39. The mean of N was 3.36, and the standard deviation of N was 0.88. Okay, so I'm subtracting random variables. I need the mean of N minus M. So that will be 3.36 minus 4.12. And when you subtract those, you're going to get negative 0.76. And for my standard deviation, I cannot subtract the standard deviations. But I can still add the variances. So I can do the variance. Okay, it's going to look like this. It's going to look like subtraction, but I'm going to take the variance of N plus the variance of M. And this is what we did in the last problem. We added those two up and we got 2.7065. And to get the standard deviation, we took the square root of that. And our standard deviation was, and still is, 1.64514. Okay, so we're going to use z-scores again. Now this time the value is 0 minus the mean of negative 0.76 over my standard deviation of 1.64514. And when I do that, my z-score is 0.46. So back over here, this will equal the probability that my z-score is greater than 0.46. Since it's a greater than, I'm going to do 1 minus. I'm going to go to my chart. I'm going to look up 0.46, which is 0.6772. Subtract that from 1, and we get our final answer. Okay, so again, we have to show that we got our new mean and our new standard deviation, our z-score, and that we used our probability statements, and then that's our final answer. So kind of a lot of work is involved with random variables. So definitely write this kind of stuff down and have it handy for when you take the AP test, okay?